Imagine a world where light can charge your devices. Each material has a threshold energy. It's not science fiction, it's the photoelectric effect. This phenomenon helps us understand how light interacts with matter in a fascinating way. The photoelectric effect occurs when light hits a material. Specifically, it causes electrons to be ejected from that material. But how does this happen? Let's break it down step by step. First, consider what light is. Light is made up of particles called photons. Metals are prime examples. When these photons strike a material, they transfer energy to the electrons. Next, not all materials react to light the same way. They release electrons more easily than non-metals when exposed to light. Now, let's understand the energy required. This is the minimum energy needed to free electrons. If a photon has enough energy, it can release an electron. Continuing on, if a photon has more energy than the threshold, the extra energy converts into the electron's kinetic energy. This means faster moving electrons. Let's consider a practical example. Imagine a solar panel. It absorbs sunlight, converting it into electric energy. This happens because sunlight causes the photoelectric effect in the solar cells. In addition to solar panels, photoelectric effects are found in everyday devices. Things like cameras, motion sensors, and even light meters use this phenomenon to function well. To summarize, the photoelectric effect involves light interacting with materials, freeing electrons when enough energy is provided. This process underpins many technologies we use daily, from solar panels to sensors. Now that you understand the photoelectric effect, consider exploring it further. Look into how it powers renewable energy or enhances technology. Don't forget to like, subscribe, and share this video for more enlightening content. Imagine walking past a solar panel, feeling the warmth of the sun on your face, and realizing that this heat isn't just comforting, it's a source of energy. When sunlight strikes the surface, vibrant photons dance around, eagerly searching for an electron to liberate. The moment they touch the solar cell, a connection is made, unlocking the potential of clean energy. As those photons collide with the solar material, they transfer their energy with purpose. Some of these electrons eagerly escape, propelled into motion, while others linger, waiting for that perfect moment to break free. Each action contributes to an invisible dance of energy conversion, showcasing the brilliance of the photoelectric effect in action. As the electrons gain momentum, they create a flow of electric current, powering devices and lighting homes. This remarkable transformation showcases the beauty of science at work, as light becomes a tangible force, translating into usable energy. With each ray of sunlight, harnessed and converted, we move closer to a sustainable future. It's a synergy where nature and technology harmonize, encouraging innovation that can change our world. Imagine the possibilities: portable chargers that draw energy from any light source or buildings that self-sustain on sunlight alone. These visions are not dreams but achievable realities thanks to our understanding of the photoelectric effect, which continues to inspire advancements in energy solutions. By embracing this knowledge, we not only enhance our technological landscape but also contribute to a greener planet for generations to come. Every photon counts, propelling us toward a brighter tomorrow, and this journey has just begun. As we delve deeper into this phenomenon, it's essential to highlight how photoelectric devices like cameras rely on this effect. When you capture a moment, light enters the lens and strikes a sensor, triggering an intricate process that converts light into an image. This clever manipulation of photons showcases the photoelectric effect's versatility, demonstrating its relevance beyond energy generation. Now, consider the impact this phenomenon has on motion sensors. When someone walks by, the sensor detects the incoming light, which interacts with the material. This triggers a response, activating security lights or alarms, illustrating yet another practical application of the photoelectric effect in our daily lives. The photoelectric effect is not just a scientific term, it impacts our daily interactions with technology. In conclusion, the photoelectric effect is a remarkable demonstration of how light can empower our technology, pushing our understanding of energy conversion and sustainability further. By harnessing this phenomenon, we pave the way for innovative solutions that enhance our future and encourage a cleaner, brighter world powered by the sun.